The next is water, right? I mean, water, very precious, whether it's drinking water, domestic life, agriculture, industry, what have you. Some people predict that the Third World War will be based on water and shared water between nations, right? So it's a very important resource. So it's a renewable resource, but it's a limited one. By that I mean, when you compare, as we build more solar panels, we don't have to worry about tapping the sun out. The sun sets and comes back again next morning. So it seemingly, it's unlimited renewable, but water is not so. We have large water bodies like the ocean, but we haven't figured out a way to get useful water out of it. Technology exists to desalinate, but it's not an inexpensive process. Our rivers and streams and rainfall, you can't have the earth come up with more rainfalls the next year. We cannot will it. So that's what we mean, it's limited. And the average quantity available to humans is fixed. Whether you're looking at the Great Lakes or the Mississippi or anything else, it's fixed. We are not discovering a new lake, right, or a new river. All of this is known. You could even argue that for natural gas, that we could come across a new source somewhere suddenly in Nebraska or Kansas that we didn't know. But with water, I don't think that's the case. And even though it's fixed, it's not constant. By that I mean, you could have bad rainfalls a particular year. So even though on average we expect so much water, it's not there the next year because we had a huge drought. Or take California, it's been going through drought for almost a decade. And the last thing is, when it comes to industry, different sectors of the industry, by that I mean, take an example, semiconductor manufacturing. It consumes a lot of water. Other industries may consume much less than semiconductor. So we have to know what kind of industry, its location, and how efficient it's about water usage as we think of water budgets. And have to make a conscious choice of not locating a certain industrial activity in an area which is water starved. Like it doesn't make a whole lot of sense to have agriculture or semiconductor manufacturing in southern Arizona, right? That's doomed to failure. So who uses water and to what extent? Well, 80% of the water is used in the agricultural sector. Another 10% is used by other sectors of the industry. So as populations grow, there will be more demand for water from every sector, from whether it's agriculture or it is traditional manufacturing, semiconductor manufacturing, mining, and so forth. So the competition will just continue to increase. And because of this, we also need to be aware of where we have more water and where we have less water. So this is according to a United Nations report. By 2025, much of Africa, Europe, and South Asia will be in a state of water scarcity. I've been to some of the countries in this part of the world, and I do know it's a felt reality that there is water scarcity. We have not dealt with that in the US, but the predictions are, at the current rate, the next on the list is China and southern Northern America. So that puts Mexico, US, Texas and so forth in that spectrum. These areas are expected to get into a state of water stress, meaning it's not quite, there's not a scarcity, but we'll have to be very careful about how we use water. And some parts of the world, like Canada, Australia, and a few parts of the world, currently they're not marked as being either in a state of water scarcity or about to become water stressed. So when we think about development globally and looking at places to locate new industries, we have to bear in mind many industries have a life of about a quarter century. So when we locate a plant, whether it's in Australia or in Israel or in Argentina or in Texas or someplace, we have to ask ourselves, how does that place stand in relation to water? Is this particular industrial activity very water intensive in terms of its need? Take all of that into account as we decide how we locate new industrial facilities. The next few slides deal with some pointers that may limit the use of certain kind of resources. Like when you're talking about mineral resources, you're talking about iron, aluminum, copper, these come from ores, right? So what happens when we deplete the rich deposit and go to the poorer deposits? We have an example here of copper. Scientists have estimated that if you go from a richer 0.1% copper ore to a poorer 0.01, that is 1/100%, from a 1/10 to 1/100% rich copper ore, the amount of energy required for smelting and transformations will increase about 100 times. So yes, we can continue to get copper, but it's going to cost us 100 times or more. So then when we get to that stage, we have to ask ourselves, do I need to commit this very pricey copper to this particular use, or will some other material substitute, provided it's technologically, it provides the same kind of function that you need, is something that we have to keep in mind. So it is energetically limited, meaning that it consumes too much energy. There's also geographically limited resource availability. So if you take stuff like iron or copper or coal, it isn't that all of these materials are available in the same percentages on all continents. They seem to be concentrated in some places and not so in others. They're more scarce. So they reflect the specialized concentrating processes dictated by geochemistry and hydrology. And so that some materials are available in all continents, some are limited to one or more continents. And a product designer needs to know that. When you design a product or a process, you have to ask yourself, if this product is used in this particular locale, will the consumers be under the mercy of resource availability? Are they going to need resources to use the product that is readily available in that nation, in that continent, or not? Let's take a look at what's abundant and what's not abundant from a geographical standpoint. When you look at this graph, you can see how some are available on several continents. Thankfully, stuff like aluminum, coal, iron, potassium, natural gas, oil, etc., lead are available on almost all continents. Some are available only on two continents, such as what? You have germanium, mercury, manganese, molybdenum, and so forth. Now you may wonder, why do I care? I don't use this stuff. You may not use this in your daily life, but you don't know what products you use in your daily life has some of these elements in the form of protective surface coating or somewhere deep in the product, right? And then only available on one continent is beryllium. Now, again, this is not an exhaustive list. Bear that also in mind. So as you can see, some are readily available everywhere, some are more limiting. The product designer has to ask himself or herself, if this product needs the following to be operational, would this work in Japan? Would this work in Argentina?